Hi everyone, this is Adam again. So today I'm just going to be going over the chapter constructions. Now I'm not going to cover every construction, okay? I'm just going to go over the ones that I think are important. Okay? So I'm not saying that the ones that I don't cover won't come up. I'm just saying that of the past papers I've done and of the exams I've seen, these are the ones that tend to come up. These are the ones that are important to know, and that's kind of it. So I'm just going to cover the ones that I think are important. Okay? So the first one is how to bisect an angle. So here we have, say, point B, point A, and point C. And they might ask you to construct the bisector of the angle. So bisect the angle. So basically what that means is, here we have an angle, we want to cut it in half. So how do you cut it in half? What you do is, you grab your compass, you put one end on the point B, and you do a little dash up here. Keeping the same length, you do another dash down here. Now, at these two dashes, you will keep the length of the compass the same. You will then place it on those dashes, and you will do quick little lines like this. Wherever these meet, this is your perpendicular bisector. So now what you do is, I am after grabbing my ruler, and so that means that this angle is the same as this angle, and therefore it's bisected. So remember, bi means two. So bisector, it just means you're decomposing into two different angles. So that's the bisector of an angle. Okay? All right, the next one is to, if you have a line like this, and say this is the point B, and they want you to either cut this in half, or they want you to construct a line that's perpendicular to this, you would do the same thing. So what you do is, you get your compass, you place it on A first, and then you make sure your compass is set so it's longer than halfway. So halfway is around here, give or take. So make sure your compass is bigger than that, and do your construction line. Now, go to the other side, put your compass on B and do the same thing, and you'll get this. These 2 points now, you grab your ruler and join these 2 points. Like that. And so now this line here is going to be a perpendicular bisector. So it's perpendicular because it's at right angles, and it's a bisector because it cuts the line in half. And this point here is the midpoint. The midpoint of AB. Okay? All right, the next thing that's important, I think that's kind of, okay, yes, there's another one. But for that sort of stuff, it's kind of, that's it. The next one you want to do is basically cutting a line segment into 3 or 4 equal parts. So again, say this is A, say this is B. What you do is, you just draw a random line like that. If you want to cut it up into 3 equal bits, then you, on this line, you just get your compass and draw out 3 things that are equally spaced apart. Okay? So you just grab your compass and you make 3 of them. Okay? The next thing you do is you go to the last one. Okay? And you draw a straight line between B and this one. Now, using your set square, carefully move your ruler, keeping the same angle, and then draw the same line here, and the same line here. Okay? So remember, your ruler stays in the same direction, and therefore these lines are all parallel. And then these three lines are then all the same length. Okay? So that's another one. Okay, another one that they can ask you to do is basically they just ask you to maybe create a triangle, and they'll tell you stuff. So they might say, okay, so give us a triangle where this is where you have 9, 7, and 5 centimeters. So the very first thing to do is I'm going to put the longest side down the bottom. So measure out 9 centimeters down here. So this is 9. And the next thing, you get your compass, you open it up, you measure it on your ruler and make sure it's 7 across. And then what you do is you'll get your compass and you'll do this. Okay, so this is 7 to there. Then you go to your other one and you'll do 5. And you'll do 5 and it might be down here. So now, wherever they intersect, that's where you're going to draw your lines. So that's going to be one line where it's 7 centimeters. Your other line is going to be from here and it's going to be 5. Okay. They could have also asked you to draw 7 centimeters using an angle. You just use your compass, put your compass on this point, measure out whatever angle they tell you. If they say, oh, it's 40 degrees, then you just measure out 40, draw a construction line. So just draw a dotted line up this way, and then wherever that meets, which would be here, you then draw that line. Okay. That's kind of it for those constructions, I would think. Yeah, there's no other constructions there that are important. Now, there's 4 or 5 more constructions, I think, and then that's it for constructions. So it's quite a short chapter, but these ones are very important that I'm about to do. Okay, so like the circumcenter, incircle, orthocenter, those sort of things, they're actually very important. And you might say, well, okay, well, why are these important? Well, first of all, straight up in the Leaving Cert, one of the questions could just be construct this. So sometimes people leave off the constructions, which you can if you want to. I wouldn't fully recommend it, but you know, if you don't want to do the constructions and you don't want to learn them all off, then fair enough. But so first of all, these things can come up like the orthocenter, the circumcenter. They can come up just solely in a trigonometry question. So they might say, oh, this point is the circumcenter of this triangle, and now solve the question. So you need to know what the circumcenter means. Okay, so you need to know what it means at least. So if you are going to leave out the constructions, you do need to know still what they are, because some of them might be, oh, it bisects the angle, and then you might need to know that to figure out a different angle to solve the problem. Okay, so it's one of those things that, yes, if you don't want to learn it, that's fine. If you want to leave the construction question, especially the way there's choice in the Leaving Cert now, well, at the time of recording this video in 2025. But the thing is, it's just, you might just it could come up in a trigonometry question and you might need to know what it is. So that's the one thing to be careful with the construction, because a lot of people do leave them off and they don't bother learning them, but just be careful with that, okay? Like, just at least be aware that if you are going to leave them off, you are rolling dice and you could be in a bad way then if it does come up in the exam, okay? All right, so let's do the circumcenter the circumcenter and circumcircle of this triangle. So just any random triangle like this. So that's A, that's B, and that's C. So the very first thing that you want to do is you want to construct the perpendicular bisectors of all these little lines, okay? So very first thing, I'll go with A and C. So again, just using my compass both times. They intersect here. And so therefore, this is the perpendicular bisector of that line. So these two lines are bisected. If I do the same thing for CB, I get something like this. So again, I'm only doing this by hand because I don't actually have a compass on me. So if this is a little bit awkward, that's why. And so where these two lines meet, that's then the circumcenter. Okay, so here, this is the circumcenter. And you might wonder, okay, well that's a circumcenter, well what's the circumcircle? If you join up with your compass, these 3 points, this distance is going to be the same as this distance, is going to be the same as this distance. So the circumcenter is basically the circle okay, that's one of the worst circles of all time. I'll try and do it a little bit better, but no guarantees will be any better. Okay, I'm just gonna leave it at that. But anyways, that's this then would be the circumcircle. Okay, so circumcircle. And then that's the circumcenter. Okay, so if they asked you to do the circumcircle or circumcenter, that's what they mean, that the length from the point to all the other points of the triangle is the same. So that's a radius, that's a radius, that's a radius. Okay? All right, now we'll do the incenter. So the incenter is basically a circle that is kind of the biggest circle that can go inside the triangle. So now if we go back to normal size, and I have this maybe. Like this, so again, A, B, and C. Now here, what they want you to do, they want to do the bisector of the angles, okay? So the bisector of the angle, so if I bisect this angle A, and get this, and this, this, and this, so this would bisect that angle. And then I'll do the same thing with C. So C, go here, here, do your compass lines and get this. And wherever these join up, and just for reference, if you did bisect the angle B, you would get the same point, okay? So this now is the incircle. And if you draw a circle in here, so if you go here at the perpendicular distance, it should be a perfect circle on the inside. So this is the incircle, and then that's the incenter. Okay. That's probably T. Yeah, and that would be the incenter. Again, where all of these would be right angles. So again, that's like another thing that you might need to know, that wherever the circle hits, it would be a right angle. Okay. Okay, that's the incircle. Now the next thing, there's another one. Yeah, the centroid. I think the centroid is also, I think it's the center of gravity as well. Yeah, so just any of you doing physics or applied maths, yeah, the centroid is actually how you get the center of gravity. So again, let's just say you have a random triangle. Again, A, B, C. Now what you do is you want the perpendicular bisector of all the sides. Okay, so if I get the perpendicular bisector of the bottom, which will be something like this, so what you do is you get this and you draw it, and that's all fine. And then basically wherever this hits here, you then draw this and connect it to the opposite angle. Okay? So now what I want to do is I want to draw this line. So now that's my important line. Okay? I'm going to do the exact same thing now for AB. So AB, if we just do it again, and we find that this is it, and then I want to join this to the other side. We would then find that this point here is the center of gravity. So this then is your centroid. So the centroid is the center of gravity. Okay? All right. And then finally, let's do the orthocenter. So ortho basically means right angle. So what you do is, so again, if we have A, B, and C, what you do is you basically just get the altitudes. So the altitude is basically, if you're doing what's the area of a triangle, and you say, oh, half the base times perpendicular height, it's just the perpendicular height, basically. So for this one, it's this. So just perpendicular height. I'll do the one at A as well. Which is this one. And again, just for clarity, if we did decide to do this one, it would also be here. Okay? So this then is your orthocenter. Okay? And that's it. Okay? So that's all the constructions that you need to know. Okay? So it's just, if they give you the orthocenter, it's just simply that you'll know that it's that. Okay? So centroid, now typically the incircle and the circumcircle come up more often, but it's just when you see them come up in papers, it'll be these sorts of ones that they're looking for. Okay? All right, I think that's it for construction. So probably not that long a video, not too bad, fairly fast. So the next chapter then is going to be trigonometry. So that'll definitely take 2 videos, if not 3. So I think, yeah, I think I'll leave it there. So thanks very much for tuning in, and I'll talk to you in the next one. Bye.